Hello and good day, everyone. Our group were tasked to share or discuss with you correlation using our programming language. I know everybody, or if not everybody, at least mostly all of us had a background information already when it comes to correlation. Today, as for our group, we have cited here three, namely the Pearson's correlation, Spearman's rank correlation, and the Kendall's rank correlation. Pearson's correlation in statistics is a parametric measure of the linear association between two numeric variables, while Spearman's rank correlation is a non-parametric measure of the monotonic association between two numeric variables. Kendall's rank correlation is another non-parametric measure of association based on concordance or disconcordance of the X and Y pairs. Now, for our group, we will be working with the lung capacity data. And as you can notice, as I open our RStudio or our R statistical software, I have already imported the data and attached it. Now, we will going to explore the relationship between the age and the lung capacity. Since I wanted to explore ang relationship han atong age nga dahan atong lung capacity, I want to ask for the class or type of variables in atong age nga natong lung capacity. To do that, I will type here class or simply click this one. And inside the parentheses, we're going to type our variable. We're going to first do this for our age. So the same way, we are going to do for our lung capacity. So we already know that both of our variables are numeric. So we are now able to continue with our correlation using the Pearson's correlation and the Spearman's rank correlation in our R programming language. So since we're going to do correlation using an our statistical software, just like what I have said earlier, we are going to use the core and core.test commands or function na aton R. Going back, the first thing that we will do is to calculate the correlation using the core command or function. Here, we will calculate the correlation between the age and the lung capacity. So to do that, we just simply type here core or click this one. And inside the parentheses, we will first input our variables. We have here age and lung capacity. And since we're going to calculate the correlation between the age and the lung capacity, we have to set the method argument. Our method argument equals to Pearson. So we'll do this first for our Pearson's correlation. So we have now the result for our Pearson's correlation. Now that we have the result, we can also be able to know that Pearson is our default if we are to leave or erase the method argument out of this command. So we will be just doing what we did earlier. But now we will not anymore including or will not set the method argument in this step for or in this section for us to be able to see and to know or to verify if an atom Pearson is as an atom default. So we'll be encoding our two variable, which is the age and the lung capacity. Or we can just simply reciprocate also our two variable. Now we can notice that the order that these variables are entered in R does not make a difference. The correlation, because, let me rephrase. As we can notice in the result that has been given to us by the our statistical software that we are been using for the demonstration para natin correlation using our programming language, we can notice that the order that these variables are entered in R does not make any difference, meaning the correlation between the age and the lung capacity is the same as the correlation between the lung capacity and the age. So if you'd like to calculate Spearman's correlation in our programming language, we can set the method argument equal to Spearman by simply doing what we did earlier. So just simply type core and we set our method argument equals to Spearman. Now we have here the result. So the same way we are going to do for our Kendall's rank correlation. So we're just going to do what we did earlier. You simply type core, and inside the parentheses we're going to type our two variable, the age and the lung capacity, and set our method argument equal to Kendall. Now we have our result for our Kendall's rank correlation. If you'd like, we can have a confidence interval returned in R for the correlation as well as the test for the hypothesis of our correlation if it is equal to 0 using the for_that_test command or function in R. Here, we're going to use now our for_that_test command or function. So we'll do this first for our Pearson's correlation. Simply type for_that_test, and inside the parentheses or inside the for_that_test value, we're going to fill in our two variable, the age and our lung capacity. And set our method equals to Pearson. Pearson. Let me check. So we have received this notice, meaning I have encountered problem in typing the our variables, so maybe I'll just simply encode na lang siguro. So for the test age, that is why we have to be crucial when it comes to typing our variables. You have to be very observant kay if an aton variable sa aton dataset is written in an uppercase, is all encoded in an uppercase, encoded or written in an uppercase, kailangan the way that how we going to input it in our RStudio is also in uppercase. So now let me do this so that I could be able to get the result. We can see we have already returned the estimate of the correlation. You can also see a 95% confidence interval for the correlation, as well as for the test statistics and p-value for the test that the correlation is equal to 0. Again, we can do the same for Spearman's correlation. We can see that by simply doing what we did earlier. Or now, we can also see that our statistical software returns a hypothesis. That our R statistical software returns is hypothesis test, although it does not return any form of non-parametric confidence interval for the correlation. We can also notice that we are given a warning message that R cannot compute exact p-value with ties, meaning we have a few people of the exact same age in our data set. So usually this isn't a big deal, but if we like, we can use the exact argument and set this to false. So to do that, we will just input core that test or core the test and I'm sorry. Yes. Or instead of encoding the whole word, we can also simply input the initials. So we have here F, which has been written in uppercase. Now we know that through our let me rephrase, by setting or by using the exact argument and set this to false, letting R know that to only approximate the p-value. We have just been telling the R that we are just like to know the approximate para natin p-value. Now, let's go back again to the Pearson's correlation test that we did. As we've seen this, the other test in R, we can use the alt argument also to change the alternative hypothesis. And to do that, something type here, core. I'm going to use the core.test commands or function, and inside the parentheses, we're going to write first our two variables, which is the age and then the lung capacity, and set our method argument equals to Pearson we have here alt or alternative argument equal to greater and a confidence interval, which stands for the dot level command or function na aton R, and this is equal to 0.99. Let me just check. Now enter. Here we can set it to greater to have an alternative hypothesis that the correlation is greater than 0. By default, the alternative will be two-sided test. We can also use the conf.level command to change the confidence level we're using. For example, we may want a 99% confidence interval returned. So that's all for our first example.